Hello, everybody.
Hi. Welcome to Fiske Planetarium's very first dome-to-home K-12 educational video. We here at Fiske are really excited to share this experience with you and bring everything we have at Fiske right to your home. My name is Rémy. I'm a presenter at Fiske Planetarium and a student at University of Colorado Boulder. Below me, we have...
My name is Jeremy. I was a CU student, and now I work at Fiske as an outreach presenter and navigator.
Awesome. So this video is for kids in kindergarten through 5th grade. So if that's you, you're in the right place. If you're older than that, you can still stick around and have some fun with us, but be sure to check out our videos for 6th through 12th graders. That will be on Wednesday. So today, Jeremy and I are going to help you learn about patterns in the solar system, especially patterns we see from here on Earth. So if you have questions at any time, go ahead and have an adult type them in the chat window or in a YouTube comment, or submit it via the link in the description. And our question master behind the scenes, Amanda, will let us know. So to start, let's go ahead and think about what a pattern is. So there are a lot of ways to think about patterns. Maybe it's something that repeats itself, or maybe it's a picture or design. You might use a pattern to make a shape, or you might notice a pattern that the mailman comes at the same time every day. So let's look at some of the patterns that we see in space. So to do that, we have to go outside and take a look at the sky. So right now, it's 11 in the morning. We're in this lovely field, and it's a nice, clear day, and it's sunny, as you can see. Let's go ahead and lay down in the field and take a look at the entire sky. So right now, what you're looking at in the dome is the entire sky. So just imagine that you've got the whole sky around you. And as time is passing when we're on our picnic, we can see that the sun is moving. And it's moving this direction to that direction. And as we're sitting here laying in our field on our picnic, we remember, hey, last time we were here, the sun was moving in the same direction. Do you remember what direction the sun sets in? That's right, the west. So the sun always sets in the west. So where I am in Boulder, Colorado, that means that it sets behind the mountains. If you live somewhere else, that might be different. But no matter where you are, every day we can count on the sun rising in the east and setting in the west. That's a pattern, right? It repeats over and over and over again. And what else do we know about sunset? Maybe about the time? It changes depending on the season. So it sets earlier in the winter and later in the summer. The sun is higher in the sky in the summer and lower in the winter, and it's because the earth is tilted. So if the sun's here and the earth's tilted, you're going to have a shorter day, right? If the earth is tilted and the sun's here, you have a longer day. And you can see right there, during June solstice, which is the longest day of the year, the sun is up for a really long time. During equinoxes, when it's an equal time, it's down a little bit lower and it goes directly west or east to west. And then during December solstice, the shortest day of the year, it's really, really low in the sky. And that's why you have really, really short days in the winter. So let's go ahead and think as the sun is setting about some other patterns that we see in space. And go ahead and shout them out loud if you can think of any.
Some might be coming up now that we're skipping into nighttime here.
So stars, yeah? So when the sun goes down, you can see a lot of stars, right? And that's how we know it's nighttime. Sun's gone. The sun is so bright that it means we can't see all the stars. So once it's down, we can see all of these, and you can see that they also move in the sky just like the sun. So they rise over there in the east, and they're setting over there in the west, right? And that's our pattern again, and that always happens. You can always count on the stars doing that. That's a pattern. But do you notice something else about the pattern? It's not just east to west. Do you see how they're spinning? So the stars are all spinning, and they're all spinning in the same direction. Because the Earth is spinning, it looks at different parts of the sky as time passes. So what else do you notice about the way that it's spinning? It's all spinning around a specific point, right? So there's a star right there that you can see. Do you know what star it might be? And here's a hint. Which direction is that star in? It's in the north, right? That's the North Star, which we also call Polaris. And it's known as the North Star because it's always in the northern part of our sky. That's because the North Pole of the Earth is always pointed right there. So while the Earth spins and all these areas are pointed at different stars, right there, it's always pointed at the same star, the North Star. So if you're ever lost and you need to find north, you look for the North Star. And here's the way to find it. So have you heard of the Big Dipper?
I have.
Excellent. Let's see if we can find it.
Right there?
I think somewhere. There it is. Awesome. So there's the Big Dipper. And once we find that, and it's always going to be in the sky, we follow one side of it all the way to the next bright star. And that way is always north. Anytime you find the North Star, that's always going to be north. And that's a pattern. We always know it's going to be there. And did you see how we added the lines to those dots to make a picture? That's another kind of pattern, right? Your pattern can be something that repeats, or it can also be a picture that we make. So you see all those dots there, and you make these lines, and you can make a picture. And here's one. There are a lot of patterns in the sky like this. A really long time ago, people looked up and they saw all the dots of the stars. They connected them with lines and made pictures, and we call those constellations. The Big Dipper is part of one called Ursa Major. It's a big bear. It's a big mama bear in the sky.
Is there a baby bear in the sky?
There is a baby bear in the sky. So mama bear has a baby bear. Remember where the North Star is? You follow that, and that's the tail of the baby bear. And there are a lot of patterns like this in the sky, a lot of constellations where they looked at these dots and they added all these lines. They thought these look like a lot of pictures. So maybe you see some lines and you think, oh, that looks like a lion. Or maybe you see they look like a dragon. There's your lion. And there's a dragon. What other pictures can you see when you look at these stars? Here are the ones that they saw a really long time ago and the ones that we use for our constellations now. There's a lot happening in the sky. We've got a swan, we've got a scorpion, we've got looks like a giraffe up there. There's a lot happening here. So all of these dots, they decided to make patterns. And those are constellations. That's another type of pattern that we see. So what sort of pictures do you see? I see a stingray. I see someone dunking a basketball. Do you see that? You know what else is up in the sky right now that I can see is the moon. So have you ever noticed any patterns with the moon? What about its shape? Have you noticed that the moon changes its shape as time goes on? So those are called moon phases. So different parts of the moon will be bright. So sometimes the entire moon is bright, and that's a full moon. And sometimes we can't even see the moon at all. That's a new moon. It's gone. Right now, what phase does it look like the moon is in? It's right, it's a waxing or a waning gibbous. So it's waning because it's getting smaller. It's going away. If it was waxing, that would mean it's getting bigger. It's getting fuller. And it goes through this cycle every month, and we call it the lunar cycle because it goes from new to full to new again. So keep an eye on the moon and see how those phases change. In a little while here, we're going to go into third quarter. That's when exactly half is lit up. And the way that you can remember how long the lunar cycle is, a full month, it's a month.
One
Full
moon.
moon, a full moon every month. So the question would be, why does it have phases like this? Why do we see parts of the moon lit up, parts of it not? And it goes like this pattern over and over and over again. Let's go ahead and go into space and find out. So Jeremy, can you take us into space?
I sure can.
Awesome.
Alrighty, almost out into orbit of the Earth here.
We say bye, Earth.
Bye, Earth. Let's go ahead and head on over to the moon, our nearest neighbor in the nighttime sky, or the daytime sky, depending on the time of the month, of the month.
So as we head over to the moon, and you'll notice that part of it is lit up, do you think the moon just shines on its own? And it's just shining different parts? No, it's reflecting the sun, right? So the same way that we have night and day here on Earth, day when the sun shines on us and night when it's not, the moon also has day and night when the sun is shining on it. And when the sun is shining on it, that's where day is. And however much the moon is lit up, that's the amount of daylight we're seeing on the moon. So right now on this side of the moon, it's totally night. So it would be a new moon, right? So let's turn on our moon cam and let's watch how the moon goes around the Earth and how our view changes as the moon goes around us every moon. So there's our handy dandy moon cam.
Go ahead and center back on the Earth here so that I can show you guys a better example of how the moon is orbiting the Earth.
So all of these visuals that we do, Jeremy is doing them live.
So here we have the Earth in the middle. The moon, that white line that I pulled up, is the orbit. So it's the path that the moon takes around the Earth in a month. And then on the top of the screen, you'll see the sun there. If I move time forward a little bit, you'll see the moon start orbiting the Earth, that blue dot in the center.
You can see, based on where the moon is in its orbit, we see those different parts of it lit up. So as it's far from us, we see that it's all lit up, and when it's closer to the sun and we don't see any of that daylight, it's that new moon. And again, that's another one of those patterns that we see, that repetition. And when we see patterns like that, we like to know how it happens, and this is how. So how long do you think it takes for the moon to go all the way around the Earth?
Maybe a month?
That's right, Jeremy, a month. So it takes an entire month for the moon to go around, and that's why that lunar cycle is a month long. So what else do you notice about the moon as you watch this moon cam here? We're always seeing the same side, right? That's kind of weird that we would always see the same side. Let's take a look. Let's make the moon a little bit bigger so we can see here, really big moon, why we might be seeing the same side all the time. So you see as the moon is going around, it's also spinning, just like the Earth spins and we get night and day, the moon gets night and day just like that too. But watch the way that it spins. It takes the exact same amount of time to spin as it does to orbit. So we're always seeing the same side. And the opposite side, sometimes they call it the dark side of the moon, but you can see it still gets light. should be called the far side of the moon. We just don't get to see it.
Sorry, Pink Floyd.
So those are our big patterns that we can see from the Earth. We can see where the stars are going, how we can see how they spin around as the Earth spins around. We can see how the sun rises in the east, sets in the west. We can see how the moon phases change and why we see that those change. And those are our big patterns. Amanda, do we have any questions? Nope. So we had some questions before. We've got, do constellations look the same from Mars? From Olivia and Arvada. Should we go take a look and see?
I think we shall.
Yeah. So we want to know, do constellations look the same from Mars? And our constellations look the same. All the way out here, you can see. So let's go to Mars and let's find out if those constellations change at all. They look the same to me. We gotta wonder why that is. Why do you think the constellations look the same even though we're so far away over here on Mars? Let's think about how far away the other stars are. Those stars are really, really, really far away. When something's far away, it's tough to see when it moves. If something is close, like say my hand in front of my face, and I move my head, my hand looks like it's moving a lot. But if I look out my window and I look at the mountains over there and I move my head the same, those mountains don't look like they moved. And that's the same here. The distance between the Earth and Mars is so small that it doesn't look like those stars moved at all. We've got another question about, why do we get seasons? So seasons, that's another pattern that we have here on Earth, right? Seasons repeat every year. So every year they repeat. We have spring, summer, winter, or spring, summer, fall, winter. I know seasons. And they repeat every year. So why does that happen? Let's go ahead and go back to Earth. Or let's take a look at the solar system a little bit, or make the Earth a little bit big. And we'll watch how the Earth goes around the sun. So the same way that the moon goes around the Earth goes around the sun.
So what I'm bringing up now, each one of these different colored lines is a different orbit of a different planet. And we'll go ahead and use the power of our virtual planetarium to move time forward a little bit.
Awesome. So we can see here, all of these lines that we see are orbits of the planets. So closest we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, really far away. So let's take a look at Earth though. Let's make it big. And you'll notice something here about Earth's orbit. There are times when the Earth is a little bit closer to the sun, and there are times when it's a little bit further. And a lot of people think that's why we have seasons, but that's not actually why. The amount closer that we are at certain times is not enough to make a huge difference. We're upside down, but that's okay. This is Earth from Australia, right?
Right.
So, exactly. So do you see, remember when I said the Earth is tilted? Like that? Do you remember how I said the sun sometimes higher in the sky and therefore longer? And sometimes it's lower in the sky and it's not there for as long. So when it's getting more sunlight and you're at that more direct angle to the sun, so like this, if this is our Earth and here's our northern hemisphere, here's our southern hemisphere, the sun's going like that, you're getting all that really direct light, which means you're getting a lot warmer. And that means that you're in summer. And then If you're in the southern hemisphere at that time, you're getting much less direct light. You've got much shorter days, you don't have as much heat from the sun, and you're in winter. And then the opposite is true. Over here, when we're on the opposite side of the sun, then we're getting less direct sunlight here in the northern hemisphere and more direct sunlight down in the southern hemisphere. So it's hotter here and cooler here. And that's why we have seasons. We have a question from Benjamin that says, how long are days on Mars? Days on Mars are a little bit longer than days on Earth, but not by much. Jeremy, do you remember?
Not off the top of my head. It's very, very similar, but it is a little bit, I think maybe a couple hours different.
Let's see. Yeah, it's about a half hour more a day on Mars. And that's just, it takes a little bit longer.
Great.
To spin around. Yeah, days on different planets last a really different amount of time. You can have a few hours, or you might have years. So how do planets move? So planets move around due to gravity. They go around the sun. So they're all going around the sun. What happens is those planets are trying to move forward. They're always trying to move forward, but the sun is here, and gravity pulls on things, basically. You get pulled by gravity. So the same way I try to jump off the Earth and I don't go flying into space, I fall right back down. That's gravity holding me there. It's the same with the planets. So they're being pulled toward the sun. They also want to keep going straight. So they end up twirling around. They spin around, they orbit. So have you ever had like a ball and a string, and you spin it around like that? That ball's trying to go away, but that string is holding it. And that can be like the gravity. It's pulling it toward you. And that's why it spins around. So that's how the planets are moving around. The planets also move spinning, the day and night cycle that we were talking about before. And those are the two big motions of the planets.
Other questions?
Yeah. Are there any other questions? All right.
Should we fly somewhere else in the solar system?
Yep, we can take a look here at the solar system and see, there are more patterns. We were talking about how the planets move. Let's talk about how they spin. So you know how we have day and night, and we have them spinning around, and all of them have day and night. Not all the planets have it the same way. So the way that the Earth goes is it spins around just like that. It's tilted, not very much. You've got planets that are really, really tilted, like Venus, that's tilted totally upside down. So it's spinning, it's almost like it's spinning backwards. Then you have planets like Uranus, you can see over there, and it's sideways. It's totally sideways, so it's spinning like that. So your day on Uranus doesn't depend on your spinning, because day comes from where the sun's shining, right? So if the sun's always shining here, that's day, and it depends on going all the way around the sun, how long your day is on Uranus. So there's another kind of pattern that we look for. Sometimes patterns work really well. We can notice the sun always rising and setting. We can see the patterns in the stars. We can see how day and night works. And then sometimes there are weird planets like Uranus where the pattern just doesn't fit anymore. All the other planets spin around and have their day and night, and Uranus is totally tilted. It doesn't make any sense. And we wonder, oh, well, does the pattern work anymore? And the pattern still does. We just have to think of a reason why it doesn't make sense in this one instance. So the question of why is Uranus totally tilted when we have such a nice pattern with all these other planets, and why Venus is upside down when we have this nice pattern with all these other planets, it's a really big question that scientists and astronomers have, because once you find a pattern, when something doesn't work, you get a little confused. So one of the best explanations that we've come up with is that something whacked Venus and whacked Uranus early on, and it tilted it.
Rémy, why does it look like the outer planets right now are moving really slow, or maybe not even moving?
Yeah. So planets that are closer to the sun, they move a lot faster. So you've got Mercury going really, 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 really fast. You've got Venus going fairly fast, but not quite as fast. You've got Earth going around once a year. As you get further and further out, it takes many, many years to go around. It can take hundreds of years even when you get really, 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 really far out there. And that's just because you have your gravity stronger, closer, and it's spinning it around much, much faster, versus way out here, the gravity isn't quite as strong. So it's going a lot slower because it's so far away. It doesn't feel the effect of the sun quite as much, the effect of the gravity from the sun quite as much. So the further you are from the sun, the longer your year, and the closer, the shorter.
How come when I change the angle that we're looking at here, why are all the planets orbiting in a flat line like that? That seems to be a pattern in our solar system.
That is another pattern. All of the planets are orbiting on the same plane, flat plane like that. So have you ever seen someone make a pizza?
Yeah, I love pizza.
I love pizza too. So you've got that big ball of dough and you're holding it there and they end up spinning it. They spin it around and they spin it around their hands and it starts flattening out, right? And it makes a pizza. So you no longer have this big glob of dough. It turns flat and it goes out, flat like a pizza. And you can see that here on the dome. You can see that our solar system is pretty flat, just like that. And those planets are all moving around, they're spinning. So that tells us that the way that the solar system was made, there must have been spinning. Because when something spins, it also flattens out. And it's going to keep spinning like that. And that's a way that we can use a pattern to see how the solar system works.
So where's Pluto? Shouldn't it be about out here?
So Pluto, everyone always asks about Pluto. So I know when I was younger, when we talked about planets, we talked about Pluto too. It was Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But Pluto isn't considered a planet anymore. And here's one of the reasons. If you pull up Pluto, Jeremy, could you pull up Pluto's orbit? It's really, really different than all the other ones. So remember when I was talking about patterns and sometimes things don't fit in the pattern and you have to think of a reason maybe why it doesn't fit in the pattern. Here, Pluto doesn't fit in this pattern, so we decided it's not a planet.
Poor Pluto.
So that is all the time we have today. So let's go ahead and wrap it up. If you have any other questions that you think of after the fact, go ahead and submit them either in a comment or through that form that I mentioned before that's in the description. But thank you so much for joining us. We're really excited to have this series going. So thank you from everyone here at Fiske Planetarium, and you have a great week.
Thanks, everybody.